A pleasant day to all of you, our future teachers and the future top-notchers of our university. Today, we'll be discussing the first unit of our subject, Gen Ed 4 or the mathematics in the modern world. But before that, please allow me to state to you the objectives of this unit. You, the students, will be able to number 1, identify patterns in nature and regularities in the world. Number 2, classify the objects according to symmetry. 3, articulate the importance of mathematics in one's life. 4, relate the Fibonacci number and golden ratio in the occurrences in nature. And number 5, express appreciation for mathematics as a human endeavor. So we all know that most of our students think that mathematics is the hardest one. Well, in fact, that is not true because mathematics is the most challenging but the most enjoyable one. Before we start, I would like to ask these questions. Alam mo, para tayong parallel lines. Do you know what parallel lines are? These are two lines that no matter how long you extend, they will not meet. Most especially nowadays that we are in the new normal, we do not have the face-to-face interaction to one another. Dahil kahit anong gawin natin, para tayong parallel lines, dahil kahit anong gawin natin, di talaga tayo mag-meet. That's hashtag masakit, no? That's the reality that we are facing right now. So, without further ado, let us now discuss the types of patterns in our nature. So, we have 1, symmetry. Number 2, we have fractals. 3, spirals. 4, chaos. So, let us deal with it one by one. So, these are samples of images with symmetry. The American Heritage Dictionary defines symmetry as an exact correspondence of form and constituent configuration on opposite sides of a dividing line or plane, or about a center or an axis. In mathematics, an object is said to have symmetry when it remains unchanged after transformations, such as rotations and scaling are applied to it. Symmetries has different kinds and they will be discussed in the next session. So these are samples of symmetry. As you can see, if we put a line in between, like for example the butterfly, if you put a line into the middle of the butterfly, the left side and the right side are the same, and that makes the butterfly a symmetrical figure. The Super Mario figure, if you put a straight line in the middle, the left and the right are equally the same. So that makes the figure of this Super Mario symmetrical and the same as the two other figures. So that's symmetry. Number 2, fractals. So these are samples of fractals. Fractals are persistent patterns which are self-similar across different scales. This means that zooming in the lens onto the object's digital image, the fractal, does not provide specifics or of a new view, but just the same as the original image. So no matter how you zoom in or out that figure, you will just have the same figure. The image clearly reappears again and again, no matter how many times the object is magnified. Examples of fractals in nature include geological fault line, mountain ranges, coastlines, animal coloration patterns, pineapples, heart rates, and the circulatory system. So all of those are fractals. All of those are mathematics in nature, in reality. How about spirals? So these are samples of spirals. So spirals are curved patterns rendered around a central point by a series of circular shapes. The spiral pattern like fractals is very common in nature from the biological molecules that make up humans to the body plans of some plants and animals to typhoons and galaxies. Some examples showing the spiral patterns in nature can be seen in snail shells. There you go, the snail shells. Typhoon satellite images and horns of ram. How about the chaos? So these are samples of chaos pattern, chaos figures. Chaotic patterns are basic patterns generated from underlying complicated behavior. So complicated but still beautiful. Unlike common concept that relates it to total chaos, a chaotic pattern is used to define a sort of order that lacks predictability. So there is no predictability unlike the first three patterns that we have. Chaos reveals the underlying patterns, continuous feedback loops, repetition, self-similarity, fractals, self-organization, and programming. Dependency at the initial stages. The apparent randomness of chaotic and dynamic systems and the unpredictable and unstable processes occur. Chaos frequently involves fractals. Examples of chaotic patterns in nature can be seen in cloud streets, cloud street tornado, and mollusk shells. So those are the four different patterns that we have in this unit. How about symmetries of our surroundings? We have three. Throughout our daily language, we refer to symmetry as a sense of balance and proportion that is harmonious and beautiful. As what was said earlier, when an object stays unchanged, it is said to have symmetry. After transformations such as rotations and scaling are introduced in it, nature is packed with patterns with particular symmetries with various kinds. So these are the different types of symmetries in our surroundings. Number 1 is reflection symmetry, 2 rotational symmetry, and the last one is the translational symmetry. Let's deal with it one by one. So this is reflection symmetry. So sample of reflection symmetry. Often known as mirrors, so the trees being mirrored into the water, or line symmetry. Reflection symmetry is made by a line going through an object, splitting into two parts that are one mirror images of the other. This is also called bilateral symmetry, since it splits the object into two, and bi means two. Bi means two. So mirror images. So that's reflection symmetry. Number 2, we have the rotational symmetry, meaning you rotate. Also known as radial symmetry in biology. Objects show this kind of symmetry when their identical parts are consistently arranged around a central axis, and the pattern looks the same after a certain amount of rotation. So even after rotating the figure, they are still the same, nothing changed. Objects and species that exhibit radial symmetry bear a similarity to a pie that contains similar parts after many lines or planes have been removed. There are no left or right side to some of these objects or organisms. However, some sources say that rotational and radial symmetries differ from each other because they do not need to shift or rotate radial symmetries to demonstrate their symmetry. And then the last type of symmetry is the translational symmetry. So meaning you just move to the left, to the right, on top, or the bottom. This type of symmetry is demonstrated by objects that do not change their size and shape even though they move to another place. Look at that figure. We have the green one being moved into other parts of the plane, but the shape is still the same. The size is still the same. So that's translational symmetry. Remember that reflection or rotation is not involved in the movement. Okay, so translational symmetry is really different from the other two. So let's have the shapes in nature. The world is packed with varying forms or shapes. So there are lots of shapes around us, around the world. Our laptop, our microphone, our ring lights, our classroom. In our houses, we have our plates, our doormats, our doors, our walls. All of these things do have their forms and shapes. Everywhere we look, there are shapes surrounding us. All that you see and can see, every person and every non-living matter. The universe without shape is very difficult to picture. Wouldn't you agree? It's very hard to picture the universe if there are no shapes. So these are some of the shapes in nature. One, we have crystals. Two, we have rock formation. Three, the animal kingdom. Crystals. So these are samples of crystals. We have diamonds and everything. Crystals are solid materials with a structure that is enclosed and arranged in surfaces with symmetrical planes, intersecting at definite angles. The crystals can be seen in snowflakes. There, the snowflakes, the rocks. We have diamonds. We have table salts and other minerals. So, what a beautiful creation, crystals. Another type of shape in nature are the rock formations. So, look at those rock formations, very beautiful. Many of the stones and rocks that we normally see every day are irregular and of various shapes. So, we cannot see two different stones with the same shapes unless it's been treated already. However, in other parts of the world, there are several rock forms where nature proves to be a master sculptor. So, like these two beautiful formation of rocks. And even here in the Philippines, we have beautiful rock formations here. And when the world gets normal, it's time for us to conquer all those beautiful sceneries in the Philippines. Take note of our beautiful scenery here in Minalungaw. So when the life gets normal, let's try to visit local tourism. Then number 3, the animal kingdom. So look at those beautiful animals. The dogs, zebras, and snakes. So between the millions of organisms that we have in the world are numerous types. So the majority of which are unusual. Looking closely, though, we can observe patterns of normal shapes that seem to be mysterious and awesome. Look at those beautiful zebras, not the humans, huh? And those beautiful snakes, maybe some of them are near you. And the dogs, the man's best friend, Dalmatians. What a beautiful creation of God. So those are the different patterns or shapes in natures that we have. So this time, let us have these Fibonacci numbers. So I know that you already discussed during high school the Fibonacci sequence. Do you still remember the Fibonacci sequence? Suppose that we have here a pair of rabbits. So a male and a female, of course. How many rabbits can be produced from that pair in that pair if it is supposed that every month each pair begets a new pair from which the second month on becomes productive. And note that no rabbits die in the entire time. So we have the first pair of rabbits. This problem may seem an interesting question for some of you, or other may think that it has nothing to do with your life. But this problem brings us one of the most fascinating discovery in mathematics for all of man's history. Excuse me. The Fibonacci sequence. The Fibonacci sequence is a very interesting math idea. It will be easy for you to understand its principle because of its occurrence in the appearance in nature, animals, and cosmos. The Fibonacci numbers were first discovered by an Italian mathematician named Leonardo Pisano. He is famously known by his nickname Fibonacci. So Fibonacci is just the nickname of the Italian mathematician Leonardo Pisano. And his nickname is Fibonacci. And the Fibonacci numbers were named after him because he discovered the sequence, the pattern. The Fibonacci sequence is a series of numbers in which each term in the sum of the two numbers preceding it. So Fibonacci number sequence 1, 1. So 1, you start with 1 and then you add nothing to 1, so you will have another 1. Then you add 1 and 1, so you will have 2. Then you add 1 and 2, so you'll have 3. Then 2 and 3, so you have 4. Then you'll have 5. And then 3 and 5, so you will have 8, and so on and so forth. So that's the Fibonacci sequence. The same is true with this rabbit problem. On December, we only have one pair of young black couple. So on the second month, of course, they will not. On the first month, they will not have their babies. So they will just have their baby after being an adult. So on January, we still have one pair. But when the February comes, red twins for black couple will be there already. So we already have two pairs of rabbits. And then the red pair of rabbits will be matured after a month, and then the black pair of rabbit will continue producing rabbits, and this is how it goes, and so on and so forth. So that's the Fibonacci number. So following the setup, there will be 144 pairs of rabbits after a year. So after 12 months, there will be 144 pairs of rabbits already. In nature, Fibonacci can be found not only in the famous experiment with rabbits, but also in beautiful flowers. Most of us probably never took the time to look very carefully at the number of arrangement of petals on a flora. If we were to do so, we will find that the number of petals on a flower that still has all its petals intact and has not lost any is a Fibonacci number for several flowers. If you want to know more about Fibonacci numbers, Fibonacci sequence, we have lots of videos, we have lots of resources in the internet, and also I will be providing you a reading material to supplement our discussion today on the Fibonacci.
This time, let's take a look at the golden ratio. Golden ratio is among the best known and most popular numbers that are studied in mathematics. The ancient Greeks gave it mystical properties and called it the divine proportion. And over the years, the number has taken many different names. The golden number, the golden section, and in the modern times, the golden ratio, which is the name we use until now. From the Fibonacci numbers, we will try something very intriguing relationship with it and the golden ratio. First, you need to pick one Fibonacci number from the series and get its ratio to the number that comes before the number you choose in the series. Let's say you choose the first number 1 in the series. You'll get the following. So 1, and the number before 1 is 0. 1 divided by 0 is undefined. Then, suppose that you get 1, the second 1 in the Fibonacci. So you will have 1 divided by 1. So the ratio is 1. And then you'll get 2 divided by 1. So the ratio is 2. The next Fibonacci number is 3 divided by the number before it, which is 2. So you will have 1.5 as the ratio. Then you have 5 over 3. The ratio is 1 over 1.67. And then 8 divided by 5, the ratio is 1.6. 13 divided by 8, the ratio is 1.625. 21 divided by 13, the ratio is 1.615. And then we have 34 over 21, so the ratio is 1.619. And then 55 over 34, the ratio is 1.618. Then 89 over 55, the ratio is 1.618. Then 144 divided by 89, the ratio is 1.618. Then 233 divided by 144, the ratio is 1.618. And as you continue the process, you will get a ratio of 1.618.
If you have any more questions with regards to Unit 1 of the Gen Ed 4 or Mathematics in the Modern World, please post it in our group chat and I will answer all of those for your clarifications. Once again, thank you very much. Keep safe and God bless us all.